This is the last bit of information that's included in that section 9.2. So chapter 9 only has 3 sections. So after the quiz, we'll review tomorrow, we'll quiz on Monday. After that quiz on that block scheduled day, we'll go ahead and we'll start the last section of the chapter, which is section 9.3. But 9.3 itself has a lot of information in it as well. So that'll take us a few days. And on to the next week to get through all of that information. So arc length and area of a sector is what we want to talk about, and this should be something that you talked about in geometry. We're going to look at it from a different perspective since we know more about radians, or we've seen radians a second time. The formulas for arc length and area of a sector are easier if you're working in radians, so we're going to work with them in radians. But I'm going to start by drawing 2 pictures, which are circles. And I want to talk about the difference between arc length and area of a sector. So when you hear the word arc, what do you think about on a circle? What's that, Elise? Yeah, the rounds of it, right? The part on the outside. And an arc could be just like a portion of that, right? Okay, so what do we call it when we do the whole thing around the outside? The circumference, or like the perimeter of the circle. But if we're talking about the length of an arc, well, that could be any size arc, right? Okay, so arc length is really something like this, the length of some curved part of the circle. I'm going to go ahead and label that S. So we use S for arc length. I'm actually not sure why we use S for arc length, but we do. I'll have to research that, probably some word in another language or something that I'm missing there. And when you think about area, what do you think about instead of like the rounds of it? You think about the inside, right? Like the shading. You did a lot of work with like area of shaded regions back in geometry. So, of course, we can shade the whole circle. When we talk about a sector, I really think about like a pizza slice. Okay? It could be any size. Okay? So, a sector is going to come from the center of the circle. And then we're talking about that area, that space in that realm. Now, it's not the area of the whole circle necessarily. It could be just a portion of the circle, right? In fact, I could have even colored in half the circle, or a quarter of the circle, or an even smaller slice. Okay, so their measurements are going to be different. Now, in both of these pictures, we're working off of the center of our circle. And remember, in algebra, what are we going to use to represent an angle? Well, what do we name angles? What letter do we use? We could have maybe used X in geometry. We could use A. What have we been using? Theta, that new Greek letter theta. Okay, so I'm going to go ahead and label these guys theta. There's some theta in both of those. Now, you probably are more comfortable naming thetas. Like if I said estimate theta, you're probably more comfortable estimating thetas in degrees, right? And I totally get that. And sometimes in an arc length or area of a sector problem, you may be given an angle in degrees. But the thing is, we're going to look at from the perspective of radians. Okay, so we're going to assume theta is in radians. Theta must be in radians for both of these pictures. Okay, so in this first picture, when we're doing the arc length, you have some theta radians, but you don't have all the radians, right? How many radians are there in the whole circle? 2 pi radians in the whole circle, and we only have theta of those 2 pi. So if we were calculating arc length, we could do theta divided by 2 pi. And that represents the fraction of the circle that we're looking at. Like, am I looking at half of the circles or a quarter of the circle? Right? It's just a fraction of the circle. And then instead of doing the whole perimeter, we just want that portion of the perimeter. So here we're saying what portion we want. Does anybody remember your formula for perimeter or circumference? 2 pi r. So what we're saying is we want a fraction of the circumference. So theta over 2 pi times 2 pi r. What do you notice is going to happen there?
2 pi's.
2 pi's are going to cancel. So arc length S is equal to r times theta. Easy. What does r represent?
Radius.
Radius. Theta must be in radians. And then S is your arc length. So if you need to label those things, you can go ahead and do that. So very simple formula. Just take your radius times your angle in radians and you have arc length. You're done. So I don't expect you to do this theta divided by 2 pi times the circumference 2 pi r. I expect you to use the simplified formula S equals r times theta. Now we could apply the same reasoning to the area, right? We don't want the whole area of the circle. We want just a fraction of the area. And that fraction is going to still be out of 2 pi. So if I worked on my area, we'll use A for area. Area is equal to the fraction theta over 2 pi. So you know if I did like pi over 2 pi, that would be 1/2. Wouldn't pi radians be half the circle? Okay. So theta over 2 pi times, does anybody remember the area formula? Pi r squared. What happens in this one? The pi's cancel. Okay, so only your pi's cancel. And the standard way that we write this is 1/2 times r squared times theta. You might see, just kind of looking at it, if you were to cancel your pi's up here, you can also write it as like area equals theta times r squared over 2. I mean, essentially that's the same thing, right? Which maybe looks more familiar, like a area of a triangle because you're doing the divided by 2. So I really don't care which way you use it. I know next year in Algebra 3 or Pre-Calculus they're going to show you this version, 1/2 times r squared times theta. So just to know that will kind of like jog that memory. Okay. So again, r represents radius. Theta must be in radians. And then you have that portion of the area. Going back to my pictures, if I'm ever working on a word problem and I'm trying to decide, like, you know, in the application problem, do I want the area of the sector or do I want the arc length? I also sometimes think in my head, like, if I drew this picture, would I be shading in like the pizza slice or would I just be following along the pizza crust? Right? So I'm always going back to a pizza on that one to make sense to myself. The arc length's like the pizza crust and the area of the sector is like my pizza slice. So let's do an example so we can see how this may work. I've jotted this down in your notebook so you have an example to look at when you're working on your problem. Find the arc length and area of a sector with a radius of 5 centimeters and a central angle of 45 degrees. You are going to be responsible for knowing the formulas for arc length and area of a sector going forward. So I'm the kind of person who learns by like writing things. So every time I would do a problem on my homework tonight, if it's asking for arc length and area of a sector, I'm going to go ahead and copy those two formulas. Because when I write them down, I learn them. You might be a kind of person, rather than writing it down, you need to say it out loud. Okay, or you need to make yourself flashcards. Study them. You decide what works best for you in terms of memorization of those formulas. You can always derive them like we did on the previous slide. Okay, before you start this problem, what you're going to be really careful about. Luke?
Putting theta in the radians.
Theta needs to be changed to radians. Okay, we can't go straight into r times theta. We can't do 5 times 45 degrees. Okay, because these formulas require theta to be in radians. We're aware of that based on how we derived it before, theta over 2 pi. So you can, with 45 degrees, you can either do your conversion. Okay, remember your conversion factor is either going to be pi over 180 or 180 over pi. If you forget which one it is, just remember you want to cancel out degrees. So you're going to put degrees on bottom, 180, and then pi on top. Some of you may also already know from geometry what angle in radians is equal to 45 degrees. Pi over 4. 45 divided by 180 is 1/4. So this is really pi over 4. Okay, so now I'm ready. S equals 5 times pi over 4. Area equals 1/2 times 5 squared times pi over 4. I know that's going to be what? 25 pi over 8. And I would argue on these problems, probably a lot of times, you might like to give an estimated, a decimal version, okay? Especially in an application problem. So 5 pi divided by 4 is approximately 3.93 centimeters. Remember your labels. And 25 pi divided by 8 is approximately 9.82. How would we label the area? Centimeters squared. Okay. So it's really, at that point, plug and chug. The question becomes next Tuesday when you guys have block scheduling and you're taking your quiz, did you prepare by knowing your formulas before you get here? I hope the answer is yes. Does anybody have any questions or concerns about how I got my answers or how we calculated? Yeah, Luke.
Would you accept it if you left it as 25 pi over 8?
Yes. If you wrote 25 pi over 8 centimeters squared, I would give you full credit. If you leave off your label, I will take off half a point. Okay. Let's see. I think I've got another. Another question. This one has 2 parts. The other part you can't see right now. It's behind the shade. But this is where we're going to apply arc length and or area of a sector. So we're on a carousel. Has diameter 25 feet. Takes 15 seconds to make one rotation. Suppose you're on that carousel for 2 minutes. Through what angle will you rotate? So go ahead and talk to your group members and see if you can decide an answer for the angle through which we rotate on this carousel ride. Through what angle are you going to rotate?
You don't have to
Whatever this one is.
No, what's
Oh, yeah.
No, your answer here is not arc length or area of a sector, correct? It's not asking that question. My question is simply, if you ride the carousel for 2 minutes, what angle do you rotate? Oh, good question. Do I want it in radians or do I want it in degrees? Well, I would say you could do either. So did groups do it in degrees? Hannah, how did your group get that angle in degrees?
So we figured out how many, times the 15 seconds are in 2 minutes.
Excellent.
And so we figured out that was 8. So then we multiplied 360 by 8.
Great. 360 by 8, and then I put that in my calculator. I got 2,880 degrees. Okay. So yeah, 15 seconds. I'm gonna go around the carousel 4 times in 1 minute. If I go around twice or for 2 minutes, then I'm doing twice that, which would be 8 times. And did any groups do that in radians? However, nobody did it in radians. However, that would be really easy for us to figure out, right? What would we do? There's 2 pi radians and 1 full rotation, and we're doing how many rotations? 8. You know what? I didn't even need to pull out my calculator for that one. So, and I know, if I'm gonna use this later on for an arc length or an area of a sector, then I'm gonna be interested probably in the radian version anyway, right? It's easier, but either of those would be acceptable. These are both true statements, since I didn't clarify which way I wanted it. Okay. And now here's my follow-up question. How many feet does a point on the outer edge of the carousel then revolve? So if you're standing on the edge of the carousel, arms and legs inside the carousel, you won't wave them outside dangerously, okay? I worked at the zoo and rides. The arms and legs inside the tram, inside the train, inside the carousel. So if you're standing on the edge of the carousel, keep all limbs inside the carousel, how many feet are you going to be rotating in that 2-minute carousel ride? So go ahead and talk to your group now, come up with a plan. Now we're applying arc length and area of a sector.
Yeah. Well, it's times the radius. So the radius is 1.5, and then find arc length is just
Yeah,
and radius is 16.
Yeah, but you're solving for the ears.
Well, it's a gradient version of the angle that I tried.
Did you just take the radius?
Oh, it's on the same.
That's what I
Sure.
did.
I don't like arc length and areas of sectors. I really
Okay, so let's come together. first step on a problem like this where you're applying and it doesn't necessarily say find the arc length, find the area of sectors, you gotta decide what you want, right? So imagine you're on the outer edge of the carousel, you're going around 8 times in 2 minutes, and we want to know how many feet we're revolving there. What are we interested in? Arc length, right? We're going around and around that, like Elise said, the round bits of the circle. Okay, so we're interested in arc length. That's S equals R times theta. Remember, for me, I know I have to know that formula come Tuesday for my quiz, so I'm going to write it down every time I need to use it. That way I'll know the formula by the end of it. And what's our radius? I'm hearing 2 different answers.
Oh, the radius.
Oh, yeah. So the diameter is 12.5, therefore the radius is, or sorry, the diameter is 25, therefore the radius is 12.5. So be on the lookout for that. If you got a picture and it gives you diameter, always make sure you do half of it. And then, which one of these angle measures will we use? 16 pi, because we want it to be in radians, so multiply by 16 pi. And on this one, probably want it, you know, like we're saying, like how many feet did we actually travel? I'm going to go ahead and put my pi into my calculator and say it was 628.32 feet. Any questions? Yeah, Jacob.
She also said just said 200 pi.
You could. I mean, like, so, like, obviously that's an acceptable answer, right? But, like, if you're thinking about reporting this to someone, if I told you that you had to run 200 pi feet in PE, do you really have a great instant understanding of what that is? No. So, like, in the context of this problem where we're talking about a carousel and a person riding on the outer limits, that's why I went straight to the decimal. On that other one where there's no meaning to it, where it just said, like, find the arc length and find the area sector, I think on that one, like, I mean, it doesn't matter. I would accept 200 pi feet. It's not wrong. But I would just say, like, when you think about it, if you ask somebody how far they had traveled on the edge of that carousel, they probably want a decimal answer, right? So it's like that question of when do we leave our answers in exact form and when do we change them into decimals? Anytime I'm answering a question about area, length, and measurements, I probably don't leave it in terms of pi unless I'm told to, because I wouldn't know that actual measurement. But no, that would be fine too. Okay, we've got about 10 minutes, so I want you working on this homework assignment. Fairly short. If you need some extra practice after you do those 5 problems, I'd go back and do the non-required problems. I'd study my formulas, okay, all that jazz.